Yay.
Is it time?
Hey.
Oh, hey,
We are on.
check that out, huh? Look at this.
That's a good-looking crowd. Hey,
Wow.
Hi, everyone.
That was just terrible.
Yeah.
Terrible. Hi.
And it's noon.
Hi.
Hey.
Oh, that's... You had coffee and beer, right? It's
Come on.
It's time to join us. Okay, so...
Before we get started,
Yeah, yeah.
we actually, if you could, we need proof that we were here so we can convince our boss that we actually weren't just soaking up the craft beer scene.
Right.
So if we can get an audience selfie.
Yeah. Ooh, whoa,
Here, let's do this.
Whoa. Okay, when we say spring, you all say... No, wait. When we say open source, you all say open source, and then smile and pretend like you're happy, okay? Wait. Wait for it. Wait, one second. This is so awkward.
Ready? We'll have to do this in multiple shots here, okay? Ready?
Ready, steady, go. Open source. And... no, okay. See... And excellent. And over here. No. Okay.
Hey, we practiced this, obviously.
Yeah. Synchronized selfing.
Yes,
All
okay.
right. Thank you.
Great.
Right on. Okay, so we're going to go through a lot of stuff. We have worked very hard on our slides. You can see that is the truth. That is a fact. That is the slide. If you have questions or comments or feedback, don't hesitate to reach out to us. We're happy to help. Or online. There's our Twitters. How many of you are on Twitter? I'm just curious. I always wonder, every time I come to this conference.
Yay.
Twitter, 2017, nay, almost 2018. Twitter. All right. Well, good. So most of you, it seems, are almost there. What about email? How many of you are using email? I'm just curious. I'm just wondering. I'm just curious. It's a thing, I guess.
A couple more, I think.
Yeah, almost as much. So there's that. Now that we have the 280 character Twitter thing, it's going to be like email. So it doesn't matter which one you do. They're both going to be miserable, right? So there's that. We forgot the code. So there's code. If you want to follow along at home, github.com, like this. You can grab the code for this project, for what we're going to look at here, in both Java and Kotlin at this URL. So if you want to follow along later, right? Not now. Definitely not now. Not now, right? The Wi-Fi is not meant for that right now. But later, if you wanted to follow along, don't hesitate to grab that code. And then let's get to it. So
Sure.
what are we going to do? We're going to talk. We're both from Pivotal. We both have the privilege of working in a small company, a small startup with big dreams called Pivotal. And at Pivotal, we have a lot of great open source software, and we care about the open source software. But the thing that ultimately drives us is this desire to help people build better software faster, to be able to move an idea from concept to customer as quickly as possible. And so we spend a lot of time talking to organizations and to customers and community members and so on about microservices and agility, right? Helping them go faster. And how many of you have heard of microservices? Oh, okay. So
Not bad.
That saves like 45 minutes of the presentation.
Yeah.
That is awkward.
So we should be done by like 2:30 now, right?
0 o'clock is sooner than later.
Yeah.
So we won't cover that, but suffice it to say that architecture has a lot of benefits. It gives you organizational agility. That said, it also invites complexity, right? A little bit of complexity because you're building a distributed system. And if you're ill-prepared for that complexity, then you're not going to like the journey. You're not going to like the result. You're going to have more pain, not less. And so we talk to organizations about technologies to address the complexity of, first of all, standing up individual production-worthy services, and then second of all, for addressing the distribution complexity, right? And introducing things like circuit breakers and centralized configuration and service registration, discovery and eventual consistency and messaging and all these other patterns. One pattern that starts to become really, really sort of important and worth focusing on when you introduce a lot of microservices is how can you most efficiently conduct data from one node to another, because that's what you're doing. You've got services that are talking to each other over the network now. Communication between components is no longer done in terms of intra-service calls or intra-process method invocations. It's done in terms of network I/O. So now you have to make that I/O, that interaction between components, as efficient as possible. And these problems only start to become manifest. They only start to become visible at scale. So you run into a few things. You run into two sort of big problems when you move to this architecture. The first is when you build a distributed system where you have potentially large amounts of data, you now need to be much more efficient in the way you process that data. Our traditional model of managing interactions between components, of managing I/O on the JVM, is not particularly great for this, right? Our traditional model is an abstraction. If you look at the input stream and the output stream, these abstractions simplify the realities of I/O. They let us pretend that the next byte will come eventually, Not too long. It'll come eventually, and we can just sit here and wait in the meantime. Because, the network is going to be there. It's going to be fast and reliable. Of course, these are the fallacies of distributed computing, right? And that's not a great thing to build a system on. So we need to be able to sort of work around these limitations that you start to face when you have unreliable systems, unreliable networks. This is not a controversial idea, of course, right? If you look at the actual way that network I/O happens at the lowest levels of the operating system, that is fundamentally asynchronous. You don't sit there and wait for a byte to come and then just block. You have a file descriptor or a descriptor of some sort, and the operating system tells you there's I/O, there's activity on that file descriptor. Please respond to it. But you're not sitting there waiting for it. You can ask the operating system to handle that for you. So we need to have that ability. We need that ability to talk about I/O in that same way in Java. And of course, in JDK 1.4, more than, 15 years? Something like that. JDK 1.4, they introduced NIO. NIO gave us channels, and that's the fundamental capability that we're talking about. It gives us the ability to say, I have a descriptor, I have a pointer to something that is a resource that has input and output, and it has activity, and I want to be notified of that when it happens. But I don't think most of us are writing our web services and our database layers and all that stuff with NIO. Are you? When was the last time you all used channels and NIO and stuff to... Yeah, not really, right? But fair enough. Most of us don't use fundamental Java I/O input stream and output stream either for our web services and our data access either, right? We talk about these things in terms of higher order metaphors, higher abstractions. So we've looked for that abstraction. What is the equivalent for this asynchronous I/O world? How do we talk about this in the same way, right? We're looking for a way to describe a large amount of data, potentially unlimited amount of data that may or may not be here. It may come now, it may come next week. What is the computing metaphor for us to talk about that? This isn't it's not like we haven't tried. If you look at the JDK, we have the completable future. That gives us the ability to say that we have one thing that will come eventually, right? But what we've lacked is a way to say we have many things, potentially unlimited amount of things that will come eventually. There's no common metaphor for that. And a lot of great technology companies out there have tried to sort of solve or to fill this gap. Right? Microsoft Research created the ARX extensions for .NET. That, of course, begat ARX Java over at Netflix. And you see Lightbend, nay, TypeSafe, they have Akka, and that certainly solves a lot of that use case as well. Vertex from Red Hat, that has a lot of the same use cases there as well. On our side, we have a project called Reactor. Reactor attempts to fill in some of these use cases as well. So there's a common enough space here that we've sort of teamed up, right? A few years ago, most of these players, all these players actually, and some more besides, got together and created something called the Reactive Streams Initiative. The Reactive Streams Initiative describes very, very simply that missing piece. It's that way to say, I've got a lot of data that will be here eventually. It's called a publisher in the Reactive Streams Initiative. A publisher is a thing that produces data. A subscriber subscribes to the data from the publisher. When the subscriber subscribes to the data from the publisher, it gets a subscription. And the client, the subscriber, can use that subscription and say, I want to request 10 more records. That's the most important bit. What happens when you move to this world where you have distributed systems producing data as fast and as efficiently as they can? Well, of course, now you run the risk of having one system overwhelm the other, right? So you need that request method. That request method gives you the ability to meter or to gate the production or the consumption of data. You can now say, I want more data, but only 10 records at a time. I can't handle 1 million right now. I can only handle 10, so just give me 10 more records. That's called back pressure. And back pressure had to be built into this computing metaphor. If we don't have it in that computing metaphor, we invite ourselves to be overwhelmed by systems that are producing more than we can handle. So we need these two things. And if you've ever built a protocol, how many of you have ever built a wire protocol using TCP or UDP? Then you know you're going to have to deal with back pressure or flow control, right? It's called flow control in protocol design. You have to deal with it there anyway. So we have now this Reactive Streams initiative and these basic types, and it's a de facto standard, and it's such a useful abstraction. Those 4 types, actually there's 4 types. There's a subscriber, the publisher, and if you have a component that produces, that is both a producer, a publisher and a subscriber, that's called a processor. So you have subscriber, publisher, processor, and subscription. These are the 4 types in that specification. It's very useful. It's so useful, in fact, that now in JDK 9, those exact same types are present. Java util concurrent flow dot publisher.subscriber. etc. So those types are now de facto standards that are in the JDK, so we can build code on top of that. But for now, it's very useful to talk about the Reactive Streams initiative. Is that enough? Can we go out and build our data access layers? Can we go out and build our web application? I think not, right? These types are very low level. They don't give us the operators we need to think about processing, mutation, transformation, filtering, all that kind of stuff. So we need more. And so this is where these different implementations can provide a lot of value. Reactor does that for us. We on the Spring team have built on top of Reactor. We've built a Spring Framework 5 that was just released last month. Brand new release. Spring Framework 5 integrates Reactor and provides the foundation for all the other Spring projects to integrate this reactive support. We have a brand new web runtime in Reactor, in Spring Framework 5 rather, called Spring Web Flux. So today we're going to talk about a number of different things. We're going to talk about Spring Boot 2.0. We're going to talk about Spring Framework 5. We're going to talk about Spring Security and Spring Data. And the thing to understand is that underpinning all of this is Reactor and these reactive concepts. Okay, so let's build an application. We struggle with this, Mark and I. We thought long and hard about this. We know that we have to build a worthy demonstration, and we thought, well, what if we had some sort of service to manage pets? And we thought nobody's ever done that in the enterprise Java space. Nobody. Yeah. It's never been done. So brand new. But we thought, no, that's not really data intensive unless you have like a lot of pets. So we thought, what if there was some sort of service where you could work with movies over the web? Now, again, in English, actually a little bit of backstory here. The Reactor Project has two specialized types. I should mention this first. The Reactor Project has two specialized types. One specialization of the publisher called a mono. A mono is a publisher that produces 0 or 1 value. It's still a publisher. You can treat it like a publisher, but it has this extra semantic understanding, this meaning, right? There's another kind of specialization of a publisher called a flux. A flux is a publisher that produces 0 to n values, potentially unlimited values. Why would you need this, this extra bit of nuance? Well, let's say you're trying to display a user interface, and you've got a publisher that comes back. Should you display a table or a text field? That's why it's useful to know if it's a mono or if it's a flux. So with that backdrop, we thought, okay, we want to have a service that allows you to manage movies over the net, and we know that's never been done before, right? This could be big. And we were thinking if we had some sort of service to manage movies over the net, and in English, it's very common, old-timey jargon to say that a movie is a flick. And what is the plural of flick? So we thought, what if we had some sort of service to allow us to work with movies over the net? We could call it Netflix, right? And so we thought we could build a service, the FlixFlux service, which is shortened for FFS, or for Flux sake. So we're going to build that first, right? Here at start.spring.io. Now, I beg your indulgence, my friends. Each time we do this talk, we switch laptops. I'm using Linux, and he's using a Mac. And every time one of us looks clumsy, it's my turn to look clumsy. So we're going to build a new application. Toss. Sorry, it's a coin toss with a very weighted coin. Shh. Yeah. So we're going to build an application here at start.spring.io. How many of you know start.spring.io? This is my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. It's the happiest place on earth. It's better than Disneyland. But if you're not already in production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application using Spring Boot 2.0 M6. We're going to call this the Flux service. Whew. Important to get that right. And we're going to use the reactive web support, right? We're going to use that. We're going to use Lombok to make it a little bit less tedious to get things like getters and setters and so on. We're going to use Actuator for operational concerns. And we need data access, right? We need some sort of data access layer. And there's a number of different choices here that we could use that are supported by Spring Data, our data access project, our umbrella project. So we could use, Couchbase. We could use Redis. We could use Cassandra. We could use MongoDB. All of them are fine choices. And these are natively reactive drivers. And we've got a natively reactive abstraction on top of them. We're not trying to stick a reactive facade on top of something that is fundamentally blocking and synchronous. So while we are heartened by the recent release and announcement of a asynchronous or reactive JDBC driver, that's not quite here yet, right? So we will wait for that to happen. But that's good news, right? Fingers crossed. Who knows? But in the meantime, we're going to stick with something that we've got. So a lot of them are good choices, but we happen to have MongoDB on this machine, so we figure we'll use that, and why not? It's a fine choice. It's reactive MongoDB. If you want to lose your data, and you want to lose it reactively. There is no better choice than reactive MongoDB. So we'll use that, right? We're going to use that. We'll hit generate, and we're going to save this on the desktop, not in the cloud. That's not a thing right now. Is that the right cloud? Why does it say iCloud?
Oh,
I'm scared.
Command Shift D.
Command Shift. Okay.
D.
Oh.
The other D.
Wait. Let's just.
There it is. Desktop.
Is it? Are we
Yeah,
sure it's going to be okay?
Yes, it's perfectly fine.
I'm terrified. Okay.
Probably fine.
You ever see that movie, The Cloud? Okay. That's command. Nope. Okay. All right. We can do this. Look at me go, huh? Okay. So here we are.
By the way, you will want to worship the mongod just to make sure everything comes out okay. We need to
unzip. Oh, yeah, okay, fair enough. So MongoD, very good, look at that. And opening this up, CD desktop, unzip this, okay, and open this in our IDE. And again, any IDE will work just fine. We're going to use IntelliJ here, but anything works just fine. Just curious, I'm always curious about this. How many of you are using IntelliJ? Just curious. Ooh.
Wow.
Gee whiz. What about Eclipse? How many of you using some flavor of Eclipse? Rock on. Also good stuff. Great stuff. What about NetBeans? Also great stuff. Anybody using NetBeans? What about Emacs? Are you here, sir? Where's the Emacs guy? Where's the one guy?
Will someone please escort him out?
Yeah. Every single city, country, and continent we go to, it's the same human being. All right. So, here we go. We've got our application. There's a temporary glitch, so we're going to switch to 2.0 M5, and that gives us the ability to also bring in security, and we're going to come back to that in a bit, right? So Spring Boot Starter security, or security reactive, right? Isn't that right? There we go. So there's that. We're going to bring that in. We're going to come back to that in a second. We're going to comment it out just for now, because it won't help us. All right, and we have now Flux service application. Can you all see that font? It's only larger than both of us combined. Can you see that in the back? Yeah? Okay, good.
Yes, no? Okay.
So we're going to build a new an application that manages entities of type movie. It's going to be a MongoDB document. We're going to give it a primary key or a surrogate key or something like that. We're going to say @ID, and we're going to give it a title field here as well. So there's that. Now, of course, we need getters, setters, toString, all that stuff. So we're going to use data. We're going to use all args constructor and no args constructor. And these are both from the Lombok project, all three from the Lombok project. And now we need some way to manage the tedious data management lifecycle of this of these entities, right? So we're going to create a movie repository, right? So here we are, and it's going to extend reactive Mongo repository. So if you've ever dealt with Spring Data, then you know what we're doing. This is fairly straightforward. This is a repository that provides data management functionality like MongoDB, for insertion, for deletion, for updating, etc. But you can see that it returns publishers, monos and fluxes, and so on, not just synchronous values. And we can even create custom finder methods. We can say flux movie find by movie, or find by title. There we are, title. Okay, so we can leave it as that. That's our custom Mongo repository finder method. And now I want to save some data in the database. So I'm going to create a sample data initializer, right? So sample data initializer, and it's going to implement application runner. Application runner is a callback interface in Spring Boot. When Spring Boot starts up, it's going to have this callback interface on these beans, and it's going to, let's see, Alt-Enter. It's going to implement that. It's going to call that run method, giving us a chance to do any kind of initialization. We can write some data to the database. So this is what we're going to do here. We're going to write some data to the database in this callback runner method here. So we're going to say that we're going to create a flux of some strings, and we want to encourage audience participation. This is arguably the most important thing that we'll do here today, is come up with some names on the theme of reactivity, in the theme of reactive programming. So we're going to start with my favorite offering from our friend, Spring Boot co-founder Phil Webb. Again, on the theme of reactive programming and functional reactive programming, but also movie titles. So Silence of the Lambdas, right? There's that one, right? Okay, there's the first one. What else do we have? What's a good one?
Well, I kind of like, is anyone an Alfonso Cuaron fan? So, ¿Y tu mamá también?
Yes.
Any Hispanohablantes here? So you know that, literally that's "and your mother" also. But if we swap out "mamá" for "mono," which is really cool, because then we get the reactive theme and an added bonus, because "mono" is monkey in Spanish. So therefore, "and your monkey" as well.
Yep,
so.
There's that. Very good.
That killed him in
What
Barcelona.
about that sci-fi movie with a flux capacitor? Anybody remember what that movie is? Thank you. Back to the Future. Very good. And there's an anime with the word flux in the title. Does anybody here know that?
Yeah, somebody called it out. Aeon Flux.
Very good. Aeon Flux. Very good. Look at that. Okay, so if you think of anything at all, we will stop and go back and add these names. It is the most important thing we can do in this brief time together. So we're going to create a publisher of type. We got a publisher of type string, right? And we want to map that. We want to create some movies out of it. So let's say new movie with a null ID, passing in the title there, and then we're going to flat map that. And we're going to create another movie. We're going to save the movie, rather. We're going to use the MR. I'm going to save the movie like this. And this could be a lambda, right? This could be a method reference, rather. So there we go. There's our publisher. And we're going to assign that to a result there. There's our publisher. Now, if we run this code, nothing is going to happen. You see, we need to activate this pipeline. It's like the Java 8 Streams API. Nothing happens until you activate the pipeline by subscribing to it. So we need to do that. So we're going to say MR, but before we do that, we want to delete everything that's in the database. Right? We want to clear out the database. You know the expression, a broken clock strikes true twice a day? Every now and then, MongoDB saves our data. And we want to make sure that we have a clean database so that we don't have the same entries over and over. So we're going to say mr.delete all, then many, passing in the movie flux, then many, mr.find all, and then we're going to subscribe here. So all we're going to do is just going to call system out print line. Look at that, huh? So now, let's see, Control R. Here we go. Let's see if that worked. Mm-hmm. All right.
Nice.
Looks like we've got data. We got it written to the database. Everything seems to be fine. What do we do now, buddy?
Well, we're going to swap seats. I'm the talkative one, so I'm going to take over at this point. Really? Nobody laughed at that? Oh my gosh. I think I need to go home. All right. So what is our next step? Well, we've already established our reactive connectivity to our data store, right? So we're going from our application down. So at this point, we probably should do something about defining an internal interface. So that's kind of where we'll go next. We'll define our service. Let's see, service, class, movie service, right? And we'll private final, maybe repository, and we'll inject that, and let's define our interface. So we'll want to return a flux of all movies, right? So we can kind of get an idea of what we have here in our stock. So get all movies. And we will also want to be able to return a particular movie, so a mono of type movie, right? Movie, boom. So get movie by ID, right? Passing in an ID for the movie in question. And then we'll also probably want to be able to, I'm just skipping ahead here. Public, boom, there we go. Public, boom, boom. We'll also want to be able to return a flux of movie events. Now, this would help if we define what a movie event is. We want to have some operational visibility into our application, right, into our service, because if we're streaming all these movies, we want to be able to tell what movies are being consumed. If we have a movie that's being watched once per year, we probably don't want to continue to have that movie in our library. If we have a movie that's being streamed 100 times per second, we probably want to look for complementary movies to bulk up our collection. So I'm going to create a class called movie event, and we'll, let's see, what we want to track. Maybe a movie ID, the movie in question, right? And maybe the date when it was viewed, right? Viewed, boom, boom. Okay, and of course we're going to use Lombok and nor constructor, all constructor, and that should get us what we need. So we'll want to return a flux of movie events so that, again, we can see what's happening within our system. So get events for a particular movie ID, right? So let's go ahead and flesh out our service API here. For get all movies, we'll just return this.movierepository.findAll. Simple, pretty straight pass-through. For our get movie by ID, return this.movierepository.find by ID, passing our ID. Again, fairly simple. Now for our movie events, this would be really easy if we had 1 million subscribers.
And we will. One
we
day.
will. At some point, it's bound to happen. But right now, we're just a little short of that.
We've got 1.
Well,
not yet. We got 0. Okay.
You signed up?
Not yet.
Okay. 0 still.
It's on the to-do list.
So if you do sign up, you'll be the first one. But until that happens, until you sign up, what we're looking at is just kind of faking it till we make it. We're going to generate a stream of value so we can kind of see what would happen if we had subscribers, right? Mm-hmm. So I'm going to do a flux.generate, and I'm going to create a sync of movie events, new movie event for our particular movie ID, and we'll time date stamp that. And that, as it stands, will just generate a crushing stream of movie events, which is great, but it's a little hard to follow in a demonstration. So I'm going to slow things down a little and delay the elements to where we get just 1 per second. And that's, whoops, let's see, what just happened there? And boom. Yeah, there we go. And this is pretty good, but IntelliJ is kind of barking at me because it's thinking I'm going to return a flux of objects. I actually want to return a flux of movie events, and that should do it. That'll define our internal API, so let's go ahead and expand that out to where we can access that externally.
Now, one thing that's really interesting is you did just delay it by a second, right?
Yes,
that's
just one value per second, yes.
So that's using a scheduler that's behind the scenes here. Right now, he's writing fairly imperative-looking code, but there's actually a thread pool. There's actually this thing that's scheduling the activity behind the scenes. And you see that above, when I wrote that data to the database, that looked like a fairly sort of declarative imperative sequence or pipeline, really, but it's actually happening in different threads, right? You don't have to worry about that. You write code in the reactive way using the API, and it'll make sure that it's correct.
Yes,
right?
you can exert the control, but there's certainly no need to.
And you can schedule custom. You can provide custom schedulers as well, of course. But by default, it's already got one that's pretty good.
Yep. So, told you I was a talkative one. So at this point, we've established our internal API. Let's go ahead and expand that out to where we can access that elsewhere. So we're going to create a REST controller. How many Spring MVC developers? Boing. So yeah, quite a handful there. So the kind of the one thing I feel like we're doing really right, and of course I'm a little biased. But one thing I feel like we're doing really right is we're not abandoning your years of hard-won expertise. Because so many times we want the benefits of a new model, but it's a little hard to ramp up. And we want to expose the full power of a reactive stack without that huge steep learning curve. So we've approached things, it's a lot more work for the Spring team, obviously, but we've approached things trying to give you options. And one of those options is in a format that's very familiar with what you're probably already well accustomed to. So I'm going to create a, let's see, request mapping, and we're going to go off the movies endpoint. We'll create a class called MovieController, and private final movie service. And we'll inject our movie service, and let's expose our external API, get mapping, public flux of movies, right? Movie get, well, we'll just call it all. And let's see, what else will we want? Once again, we're going to want to access a particular movie. So public mono typos mono of movie, right? By ID, and we're going to leverage a path variable to grab our movie ID. And finally, we're also going to want to get our events for a particular movie. So events, public flux of movie event, events. Once again, path variable, string ID. And let's go ahead and implement these. Return this dot movie service dot get all movies. Again,
easy.
Straightforward, simple pass-through. Return this dot movie service dot get movie by ID, passing the ID. Again, very simple. Here we're going to do a this dot movie service dot get events, passing the ID, and that's close, right? But by default, REST controller we're returning application JSON, and at this point we have an indeterminate number of events, 1 per second, as we've already seen. So we need to somehow signal that we should keep that connection open. Now, Project Reactor does, I keep leaning against my cord here. Project Reactor does leverage WebSocket. It also allows you to implement things via server sent events. Since we're sending a pulse one direction every second, it makes a lot of sense to go ahead and leverage server sent events. So I'm going to point out that this produces a media type, specify this produces a media type of text event stream value, which is enough to go ahead and signal that we're going to be producing a stream of server sent events. So let's go ahead and restart this. Let's see, go here, clear. And yep, we're up and running. So if we hit our endpoint, we'll go here and test that. And we have a winner. Okay, so there are movies. Everything's coming back. And that's the second most important part, right?
Third.
Yes.
Yeah.
Oh, third. Okay, I lose track. So let's grab a particular one. We'll start with Back to the Future. And we'll see if we can retrieve that particular movie, that mono-type movie. And yes, indeed, we did. So let's go back here and we'll see if we can get our stream of movie events. And we're up and running. Okay, so everything works. But we can fix it, right?
Absolutely.
Yes, we can fix that. So that's one way. If you're coming from a Spring MVC world, that works really well. So again, this is a very low ramp, low on-ramp. The only thing that really looks different is your return types. Everything else is kind of the heavy lifting is done by Spring Data, which is very, very nice.
And one thing you should keep in mind here is that this is not Spring MVC, is it?
Oh, right. Yeah. I mean, and that's one thing I kind of hinted at earlier, because the Spring team, rather than just wholesale replacing Spring MVC, which would be kind of silly, right, created a parallel packaging of Spring Web Flux. So it allows you, again, very similarly to use something that you're very accustomed to, but the capabilities are actually leveraging different modules within Spring.
So what server are we using here?
Oh, gosh, I keep skipping over things just quite lightly. With Spring MVC, you're leveraging Tomcat by default, and you can obviously control that. There are interchangeable options. Same thing here. We're using Netty as our baseline for our container, but once again, you have options. Any Servlet 3.1 container will work. However, Netty is kind of the first mover and well established in that regard, so we're using that as our default, our foundation.
So it looks like Spring MVC, walks and talks and quacks like Spring MVC, but this is not Spring MVC. Right? This is a brand new Reactive Web Runtime. Say that fast 3 times.
Reactive Web Runtime. Okay, yeah. And I'll stop at 1. I think that's pretty good.
And it's optimized to handle large amounts of data. So we could return service and events until the heat in the universe expires, and that thing will keep going as long as it's plugged in, right?
Yes.
And the client won't ever run out of memory. It's going to only produce data as it has it. Whereas Spring MVC, by default, a servlet-based Spring MVC would attempt to wait for the last byte, the end of file marker, and then transform it into JSON and send it back. Here we're doing it incrementally.
Do you want to go ahead and do you want me to go ahead and do the functional? Okay, I just want to make sure because I'm keeping an eye on the clock.
My favorite.
We want to make sure we get you out of here in an hour and 18 minutes, right?
Yep.
That's all we have left.
Yep.
So I'm going to again, I mentioned that we can fix this. If you're not coming from a Spring MVC world, if you're coming from a more functional reactive type of background, that is all well and good, but it's probably not what you're used to seeing. You have options. So what I'm going to do is create a router function of type server response, right? And we're going to create a router function here, which will allow us to define in a more functional reactive manner our routes, right? We're going to define our endpoints. So I'm going to first start off with let's see, router functions dot route. So we're going to create a route. We're going to define a request predicate dot get, and let's see, we'll start off with our movies endpoint. Now at this point, what we could do is specify a new handler function, which this always makes me cry a little inside, right? Because what do we have with handler function? We have a functional interface with a single abstract method. So what can we use to implement that? Thanks to Java 8. All we really care about is this, right? We want to be able to handle a server request and return a mono of type server response. So one way that you can do that, kind of a nice clean way, is to define a component. We'll call this class movie handler, right? And we're going to, once again, leverage our movie service for our internal API. And then we're going to define some handler functions, right? And let's do that. So we'll start off here and we'll create our all method, which once again will return a server response.OK. It's all OK. Whoops. Let's see. What we want to do here is create our body. So we're going to leverage our movie service dot get all movies, and we're returning objects of type movie, right? Pretty simple. The next handler function we want to create is our by ID, which once again accepts a server request, and we're going to return a server response.ok.body, leveraging our movie service, get movie by ID, and we're going to take our request and extract our path variable for ID, right? ID. And finally, for our events method, we'll return a server response.ok.body, movie service.get events, once again passing our request path variable, extracting, so on and so forth. But at this point, we need to specify once again that we're leveraging server sent events. So we're going to specify our content type. So let's see, media type dot text event stream. And now we can go back up here and get rid of this ugly monstrosity. Yes.
What kind of data are we returning?
We're returning a mono of type server response, right?
Down there in the publisher.
Gosh, I forgot that. Whew, good catch. Boy, and I forgot that up here too. Ouch. That would have been fun. So here we're returning a movie. And of course, for our events, we're returning objects of type movie event dot class. There we go. Thank you. Good catch. That would have been embarrassing. Front row. I always count on the front row to catch my stuff, and everybody was just too quiet. So, ouch. Okay, so now we can get rid of this ugly monstrosity, right? Well, we will be able to if we pass our movie handler. We'll inject that. So now we can take our request, do a handler dot all, passing our request, and if we want to add a route, and of course we do, so we can do a request predicates dot get once again for our movies ID, right? And once again, passing our request to our handler for by ID. And finally, for our last route, we'll do a request predicates dot get for movies slash ID slash events. So we can grab our events. So handler dot events, passing our request. And that looks pretty good, but I think we can do a little better. We can do a little code cleanup. When we have a single parameter lambda, we can replace that with a method reference. So we just do that. We clean that up just a bit. And then we do some, whoops, it's like I'm on your machine again. And then we'll actually do a little bit of cleanup here with some on-demand static imports. So that, come on, there we go. That is nice and clean and concise and readable.
Yep.
So
All
as
the
long
routes
as
in one place.
As long as we don't have any typos, we should be up and running. So let's verify that. Oh,
Return.
Missing return statement. Oh, okay, front row. No t-shirts for you. All right, so let's do this again. I guess I forgot to tell you, so it is back on me. But I really count on the front row to catch my typos. So, okay. All right, so let's see what we have. Clear this mess. And let's hit our movies endpoint. Oh, so nice. Look at that. Let's grab Itumono también, and let's see what that works. Yes, it does. So let's go back to our events, and we'll see if we are streaming our server sent events. And yes, we did it. Okay, so
Same style.
That all works.
Same results, two different styles.
Two different styles. The choice is yours. Oh, and now I'm flat on my chair. I'm free.
All right, so that was
Tag.
great. Tag, yeah. So thank you. So we've looked at two different ways to implement the same REST API. Why would you choose one or the other? Well, it's not an either or. You can do both. One is nice because you have all the routes in the same place, and you can have the endpoint mapping and the custom request predicate logic in one place, and then you can have the handler that handles it all in one place, as opposed to using the Spring MVC style controllers where your annotations are declarative. They're not programmatic. They're not. You can't change them beyond the options that the request mapping annotations give you. And also, those annotations live in your code, so they may be sprawled across different packages and so on, and it might be hard to get a single bird's eye view of all the endpoints that are in your application. But it's either or. It's a matter of style. Do what you like. Obviously, there's a lot of other technologies that have endpoint mappings kind of like this, right? So in the Ruby on Rails world, they have Sinatra, for example. So this is it's a style choice, right? And you can do either or both. So okay, we've got this now. Are we done? Can we go to production? I think not, right? There's a number of sort of production concerns that we need to care about, like observability and like security. So let's talk about that. When we talk about observability, we usually think about things that help us figure out what's going wrong with the system if something was going wrong, right? So in Spring Boot, we have this project called the Actuator. The Actuator provides a set of endpoints that you can use to visualize or to understand or to surface information about the application as it's running, right? But in order for us to use that, in a reactive world, we had to do a little bit of work to make that work in Spring Boot 2.0. Because now the Actuator, which used to be an extension, or it used to depend on Spring MVC, now works independent of Spring MVC. It works in Spring Web Flux, it works for JAX-RS, and it works for Spring MVC as well. So in order to enable that, we have to say management dot what are we saying? Endpoints dot let's say health. Let's say we want to enable the health endpoint. There we go. So all I'm going to do is I'm going to enable that one endpoint. We won't spend too long here. This isn't strictly speaking, this isn't unique to the reactive world. It's just kind of interesting. So there's that. There's our there's actuator endpoints. You get that. So let's see, HTTP clear. Yep. HTTP :8080 /application / health. Okay, there's that. So we got some health endpoints, health information that works in the reactive world. Now, another concern is security, right? We need to be able to lock down this application. We couldn't deploy an application however fast if we had no security. And if you think about how security works, normally there's how many of you have ever used Spring Security? I'm just curious. Yeah, okay. The overwhelming majority. It's very prolific, very pervasive, very, very useful. It's been around for more than a decade, so it's very, very stable. There's a lot of great integrations. And that the fundamental sort of assumption there is that you've got some sort of security context. And that context has to be propagated whenever you need it. You need to be able to say, what is my current authenticated principal? That is typically managed by a thread local. Well, that doesn't work in the reactive world, does it? So we had to rework some of that in Spring Security to make that work right in the reactive world. Spring Security 5 is natively integrated with Reactive, and we can take advantage of that here. So what we're going to do is we're going to go back to our build, and we're going to bring in Spring Boot Starter Security Reactive, just as we had before. And I won't spend too long with the possible options here. Let's just we'll handle security for both authentication, which is to say answering the question, who's knocking at the door, and authorization, which is to say, what can that person do once inside the house, right? So we're going to say security configuration at enable web flux security and at configuration. And inside this configuration class, we're going to say at bean, and we need to return a user details repository, which is this is how we're going to answer the questions about authentication. You can use any number of different systems, but I want to have a simple example where I'm just going to hard code users in my in-memory example. So user dot with username JLong dot password is going to be PW because of course it's PW. The roles will be user and the then I'll build it. And then we're going to also whoa easy. Then we're going to copy and paste that, and we'll paste that here, and we'll use we'll build another user there, and we're going to give that to mkheck. There we go. That's Mark, and of course Mark is an admin, right? We'll give him keys to the kingdom there.
Wow, that's scary.
So there we go. There's authentication. Now that is useful by itself. That'll actually lock down the application and require that there be an authenticated principal for any access to every endpoint. So if I did that, that'd be a start, right? I could do that. And here I could say curl HTTP localhost 8080 / movies. Doesn't work, right? If I up Control A -v verbose, you can see that it says 401 unauthorized. Now if I go here again, I say -u JLong PW. There we go. There's the data on the bottom there. That worked. Now let's introduce authorization. Let's make it so that only the authenticated admins have access to any of the data. So here we're going to create a security web filter chain authorization. And in order to do this, we're going to inject the HTTP security builder for Spring Security. And this is fairly simple. We say security dot HTTP basic and authorize exchange dot any exchange has role. So it has to have this role, right? There's that, and let's see, and dot build, right? There's that. There's my basic authorization. Okay, so restart that, and we'll go back here. Now the same request that worked before, that same request that worked before no longer works. You can see it says 403 forbidden. So try that again now with a more reasonable human being. Here we go. MKHECK. Did I do that wrong?
Typo in the end.
Awkward.
At the end. Yeah, you've got...
Oh, thank you. Ha.
There you go.
Look at that, right? He got access to the service. So we've now secured the application using Reactive Spring Security. Again, easy to do, easy to get right. Now, we should build a client.
We should.
We should build a client to talk to the service. So let's do that. We're going to build a client. And again, we could use, we're going to build a brand new client using a new service. We could use all the normal stuff, right? We could use the REST template here. But again, as with Spring MVC, which is geared towards having the end of the payload and being able to map it all to a single response, we need something that, for the client, we need something that allows us to talk about a potentially unlimited amount of data, right? So instead of using the REST template, we're going to use something new here.
Okay, so all I've done is create a client application, or the shell of one. So now let's go ahead and create one, right? First thing I'm going to do is eliminate any port conflicts. That's always a good thing, because when you forget that, that's always a little
There's a
awkward.
conflict.
Yes, there's a conflict. So I'm going to, once again, redefine what our model is. So class movie.
I think it's okay to do that thing I said we could never do. Ever.
All right.
The one thing that we can never do, not even when we're all by ourselves at home and nobody's looking.
But we have 4.5 minutes. I can do this in 30 seconds. Okay.
This is one time. You can copy and paste.
All right. Well, I'm going to take advantage of this because it's happened so rarely. So, of course, we don't need to worry about Mongo. We have a backend service to that. So this is good, right? Let's see. Almost. Let's see. Data at all-args-instructor, and that should be good, right? So, okay. So, what do we want to do? Well, the first thing we want to do is create a web client. So, web client, web client client, return web client dot build, right?
Yep.
Builder dot, yeah. See, I always get turned around on the security stuff because even though he put me as admin, he's actually far more trustworthy than I am. So, let's see.
Filter.
So, we want to filter, and we want to, let's see, basic authentication. Filter, right?
No, just go back. Basic authentication has 2 parameters.
Oh, yes, of course. Okay, so let's see. Yeah, well, you sure you want to trust me?
Yeah, well, you're the one with admin.
Yeah, that's true. Okay, so PW and let's see. .build, right? Here.
You have to base URL.
Oh gosh, good point. Yeah, we should probably do that. So where are we going to hit? We're going to hit our movie service. So 8080/movies dot build. Yeah, much happier. Okay, so at this point we have our web client configured, secured, hopefully securely. So now I'm just going to do a command line runner, just in the interest of time, so we can create our demo. And I'm going to inject our web client here. So now let's get started here. So return string args, boom, boom, and there's our lambda for our command line runner. Now, let's do this. Client.get, right? So we don't need a URI because we already have that. Let's retrieve. Let's convert our body to a Flux. In this case, we're going to be bringing in movies to start with. Let's see, and let's filter. So let's filter out to grab a particular movie. So movie.getTitle equals ignore case. What movie do we want? What one is our favorite? Let's see. Okay, Silence of the Lambdas it is. Let's grab that. Boom, boom. Okay, so now let's flat map that, right? And let's take that movie, and we'll once again do another client call. So get.URI, and we're going to add on to our existing base URL, URI, with events, and we're going to leverage our movie.getID so we can grab a particular movie, the movie that we're passing in. And then we are going to retrieve that, and we'll convert the body to a Flux. Again, in this case, we're grabbing the movie events, and then let's subscribe to that so we can see what's going on, because it's always good to see what's going on, right? Assuming it all works as
big
advertised.
Assumption. Big leap of faith.
Big assumption. But here we go.
Semicolon.
Oh, can you tell I've been doing some Kotlin lately? So let's run this now that we have our required semicolon and see what happens. Oh, look at that.
Gorgeous.
It actually works. So yeah, everything has worked so far. What is going on?
Secure and reactive. Now, we have just a minute. So I think we should talk about microservices and distributed systems. No, I'm just kidding. We don't have enough time. We have just begun, though.
Yes.
Seriously, this is just the beginning of the discussion. We have looked at absolute basic stuff here. We've looked at Spring Boot 2.0, which is due in December. We looked at Spring Security 5, which is due before December. We've looked at Spring Data K, which is already GA and released.
Yep.
We've looked at Spring Framework 5, which is GA and released. This is the foundation, though. You'll see Spring Cloud Finchley, which is our microservices framework. That will be updated. It is already, you can already try it out. Spring Cloud Finchley milestones, my M3, for example, has support for reactive programming for all sorts of different things, for client-side load balancing, for service registration discovery, for the circuit breaker, for eventual consistency in publishing and messaging, and integration with Spring Cloud Stream. All that stuff has been updated to work correctly in the world of reactive APIs. We have beyond this, we have plans to integrate Reactive with a whole bunch of the other projects in the Spring ecosystem. So while we've talked about a lot of stuff here, it is just the beginning, and this is hopefully a valuable thing for you, or a good opportunity. So with that, I want to say thank you so much for your time. What did you think? Did you get something out of this? I'm just curious. Did you see something out of this? Okay, good. We know that we went through a number of stuff, so don't hesitate to grab the code there, grab the bits. We're very happy to answer questions if you have them outside. Thank you so much.
Thanks.
Thank you, Mark.
Thank you.
That was so great.